Hello everyone, welcome to Engineering and Economy. I'm Dr. Nathan. Today we are going to discuss about various types of solar PV inverters. So these types based on its application. So we can divide into four different categories. Those are standalone inverters, also called as off-grid inverter, and grid connected inverters, also called as on-grid inverters. So please go and watch the previous videos about what is meant by off-grid and what is meant by on-grid systems. That will help you to understand better about these standalone inverter and grid connected inverters. Then we have a battery backup inverters, and finally we have a hybrid inverters. So usually we understand what is mean by inverter, what is the function. Now we are going to go for different type of inverters based on their application. So based on the application, the inverter designing companies or inverter manufacturers produce different types of inverters based on their application. Because inverter is a expensive electronic equipment that is necessary for solar PV based power systems. So in that case, the manufacturing company, they produce different types of inverter based on your needs. So we'll look at one by one. The standalone inverters. So standalone inverters is a power inverter that convert DC current into AC current independently of the grid. So it's not depend on the grid. Okay, standalone system itself, it's not connected to the grid. So these inverters are self-independent. It can convert DC current, whatever solar PV produce, that DC current into AC current without the help of the grid. So these are the standard inverters. So these are a little bit expensive because it has an electronic component which can get its own power to start converting DC power into AC power. It's because to initiate the inverter function, there should be some power, the energy needed. So that itself, the standard inverter itself has a kind of battery setup that can power the inverter to operate. So we need the power energy to operate the inverter. Then the what is the operation of the inverter? Inverter convert the DC current into AC current. So this entire function is done by these standalone inverter independently. Okay. Then we go over a grid connected inverters. Connected inverters is very simple. That it uses the grid supply power reference, the voltage current references from the grid supply, and use that grid energy to initiate the process of converting DC into AC. So as I said early in the early videos, so 90 percentage of the inverter we have are grid connected because it's the cheapest or least expensive or low cost equipment. The inverter among all the inverters, grid connected inverters are very simple and the cost is less because we have a grid supply. Based on the grid supply, the function of the inverter depends on the grid supply frequency and the current. So you take the reference frequency and current from the grid supply, then it starts. So what is the disadvantage is that whenever there's a power cut on the grid, then this inverter will not work. So because you need to understand that if the inverter want to work, it needs some energy, so the power. So that power, it's this inverter getting from the grid. If the grid is not available, but you have a solar PV DC current, there's no use because if the grid is shut down, this inverter will not work. If this inverter will not work, then whatever DC current you have from the solar PV, that is not going to convert into AC. So that is the negative side of the grid connected inverters. So many people do not know that when they have a grid connected inverter in the daytime, if the grid shut down for some because of power interruption or some failure and many other reasons, if your solar panels are producing energy that cannot be converted and as into AC. So your house in the daytime it cannot get any energy from the solar panels, because solar panels produce DC current during the daytime, but it cannot convert as AC, because this inverter need a grid supply to operate. It start its operation if we have a grid supply. Okay, if we don't have a grid supply, then this inverter is dead. It's not going to work. Okay, so then we go for a battery backup. Next thing is a battery backup inverter. So if you look at this diagram, it's very simple. Um, we have a solar panels. The solar panels connected to the charge control, then connected to the battery. And if you want the DC load, you can operate directly from the charge controller. If you have any chargers or any DC loads, DC load, AC loads. Okay, then from the battery it goes to the inverter, then come to your house. So this is your house. Okay, this is your house. So from the inverter, this is come to the house, and the inverter, the battery, from the battery it goes to the inverter. Okay, this is called the battery backup inverter. So what is happening here, I mean, whatever energy DC the solar panels are producing, that is stored in the battery first. Then after that, from the battery, inverter pull the energy, DC energy, then convert into AC and supply to the load. Okay, so here battery backup inverter first priority is storing the energy. So whatever daytime or whatever time solar panels are producing in the early morning or late afternoon or whatever time, whatever solar panels are producing, first preference is to store it in the battery, then use it from the battery. So it is called battery backup inverters. So we can see one more diagram. It's given in here. So here is a panel, and we have a charge controller, and we have a battery. From the battery it goes to inverter. From the inverter it goes to the loads. Okay. Okay, this is how the battery backup inverters work. Okay, battery backup inverters always you have a large size, quite large size, 120 amp hour, quite large source of battery. So here the inverter always get power from the battery. So battery is most of the time battery is charged. So there's no problem of how the inverter get energized. So inverter get the operating power from the battery itself, and the DC current also from the battery. So same source to make it inverter work and convert the DC power into AC power. So next we go for the hybrid inverter. So hybrid inverter is advanced one. It's a combination of all the function included in the hybrid inverter. The hybrid solar inverter is a piece of equipment that is created by combining a solar inverter and a battery inverter into a single unit. Okay, solar inverter and the battery inverter. So solar inverter mean whatever solar panels directly go to the inverter and convert into AC, that we call solar inverter. And battery inverter mean whatever the energy stored in the battery come to the inverter and convert it into the AC. This allow the hybrid solar inverter to intelligently handle power coming from your solar panels, solar batteries, and utility grid all at the same time. So what is the beauty of hybrid inverter mean? The other types, the input only can be come from only one resource. Okay, either for inverter, we are talking about inverter. Inverter has an input and output. So other type of inverter is sitting here. Input can be come from the solar panels. So there is a solar PV inverter, simple solar PV inverters. And another inverter, the input can be come from the battery. So the battery backup inverter. And another inverter here, in the hybrid inverter, input can be come from any place. Okay, let's say sometime input come from the battery, sometime input come from the solar PV, sometime input come from the grid. Okay, hybrid inverter basically this inverter can even convert the AC current into DC current. It has both functionality, DC to AC and AC to DC. So what is a question here, why we need a hybrid inverter? Okay, let's say you are going to charge the battery using the grid power. Okay. Okay, this is again you can ask question, why we want to charge the battery using grid power? Because in developed countries they say like in off peak hours you can consume power from the grid in a low cheap price. Okay, off peak hours you can consume power from the grid in a cheaper price. So what we can do in off peak hours, we can buy the power from the grid and store it in the battery, and we can use it in the peak hours to our house. So it's an energy management tactic, the strategy, like okay, during the lowest cost hours, okay, whenever the cost is low, that time I'm going to buy the power from the grid and store it in the battery. Now question comes, okay, how can I buy AC power from the grid and store in the battery? Then the hybrid inverter comes, because hybrid inverter can convert AC power into DC, and because battery can be charged by only DC power, so the hybrid inverter can change the AC current into DC current and store into the battery. Again, can we have different inverters? No, we need one inverter which can do all the performance. So another scenario comes, okay, now I don't want the grid, I want to charge the battery from the solar panels. Okay, that time these hybrid inverter work as a smart device which work as a charge controller as well. And because the charge controller is inbuilt within this hybrid inverter, is a hybrid inverter is a smart electronic device. Okay, now the DC power from the solar panels will used to charge the battery. Okay, so this is the function of the hybrid inverter. We will put another video separately how the hybrid inverter working, so you can understand now the why we need different inverters for what is the purpose. And hybrid inverters are expensive, super expensive compared to your normal inverters, grid connected inverters and battery backup inverters, because hybrid inverters can do any performance, any performance, like what I am saying, like if you want to charge the battery by using half of the energy from the solar PV, half of the energy from the grid, it's possible using hybrid inverter. Okay, you can tune it. Okay, take 40% from here, 60% from here. You can tune the inverter, and you can program the inverter to make whatever performance you want to make it. Okay. Okay, so grid connected inverters, we can typically grid connected solar PV inverters which are during the blackout. Okay, why grid connected inverter will not work during the blackout? There's another question, why you can ask why it is not working. One thing is that grid connected inverters use the reference voltage and frequency from the grid that used to turn on the inverter. First thing. Second thing is, for the safety reason, we purposely make the grid connected inverter going shut down during the whenever grid not available, because we don't want the during the power shutdown in developed countries. Power shutdown happens mainly for 90% of the cases, mainly for to work repair the grid lines, repair something, repair the transformer, repair the poles and wires, or some maintenance purpose or repairing purpose. So this the problem is here, right? If you do not make this grid connected inverter to shut down during the power cut time, the solar panels, whatever energy produced by solar panel, can be sent to the grid. Okay, now the workers are working on the grid. Okay, because of the maintenance, the electricity workers are working on the grid. I don't want my solar panels to send its energy and its power to the grid. If we are sending the power to the grid while people are working, it's a danger. They will get shocked, they will have impact. So to avoid that impact, for another safety reason, we are making grid connected inverters to going off, shut down while grid is not available. So however, there are many ways to make these grid connected inverters to convert this into the self-independent inverter. Those are the battery backup system, hybrid system, backup generators. Okay, you can modify these grid inverters by doing these kind of arrangements. Okay, making battery backup, hybrid, making hybrid, and using backup generators. Okay, so we understand already the grid connected inverters always work while the grid is available. Okay, hybrid inverters we already understand. That's all for today discussion. Thank you very much. Please subscribe this channel and provide your support. Thank you.